the way. Let's start unit 2. Okay, so this is a problem that was on your exam, writing the balanced equation for a compound between 2 ions. So the first ion that we have is K+. Okay, so that's going to be potassium with a positive charge. And the second one is oxygen with a charge of -2. Okay, so right now, do we have too much negative energy or too much positive energy? Yeah, it's too much negative energy because there's O2 minus, but potassium is only +1. So how many potassium ions will I need in total to balance out the oxygen? 2, yeah, because if there's 2 of them, it's +1 +2, which means when I'm writing the equation, I'm going to need 2 potassiums, okay? So again, this number in the front tells us how many ions you need. So these are the separate ions that we need. Okay, plus O2. So what this is telling me is I need 2 potassiums and I need to combine it with 1 oxygen ion, and that's going to form a molecule, a compound. Okay, so just looking at the left side, how many potassiums did I use? 2, yeah, we're using 2 potassiums. So the molecule that we make is K2, and then we only used 1 oxygen, so K2O. So this is what you should have given me for the final answer, okay? So everything in the box is what you need to give me. Okay, and I know that this was on your exam and some of you guys might not have gotten it, but that's okay because we're gonna keep doing this for the rest of the unit. So if you guys didn't get it, that's okay because you have a lot of time, but we need to keep doing this. So just make sure you guys understand it. Okay, and so the left side is what we call the reactants, or the things that we start off with. And then the thing on the right is what we call the products, the thing that's made. Okay, so basically there were 3 ions, 2 of these, 1 of these, and they made this molecule. Okay, all we're doing is we're balancing out the charges. Okay, so just make sure you guys have that written down somewhere because we're going to be doing problems just like this basically for the entire unit. Okay, and again, if you guys have any questions about this, you can ask me during independent work time, or I have tutoring sessions during my conference 1 and 2 and during lunchtime every day. Okay. All right, so with that being said, let's move on to the new concept. So we're not really going over anything new today. We're just kind of adding one small thing onto this, okay? So let's move on. Okay, so you guys don't need to write this down because we've learned this before, but we learned that positive ions, right, and negative ions, cations and anions, they're attracted to one another, right? So again, you don't need to write this down. We already learned this. Okay, the ions that we've been looking at so far are just one ion. Okay, right? So we have K plus, O2 minus, right? P3 minus, Mg2 plus. Everything we've looked at is just made out of one atom. Okay, one atom. But some ions are made out of more than one atom, and those are called polyatomic ions. Make sure you guys write this part down. Polyatomic, yeah. Poly means lot, a lot. Okay, so a lot of atoms. So ions that are made out of more than one atom. Okay. So that's what we're going to be covering today, and we're going to be looking at polyatomic ions basically for the entire unit. They're just the same thing as regular ions, except that instead of being made out of one atom, they're made out of more than one. And I'll show you guys what that looks like in a sec, but just make sure you guys copy that down. Polyatomic ions. So it's an ion that's made out of more than one atom. Okay. And as usual, if you guys want to follow along with the lecture on your Chromebook, the notes are on Canvas, and I am recording this right now. And so you guys can re-watch this video if you guys have any questions. Just make sure you like, subscribe, join my Patreon, my Discord, smash that subscribe button, and I'll put you guys in the credits of the lecture if you guys donate. I'm just kidding. Whatever all those people say. It's YouTubers. Okay, so Polyatomic ions are atoms that are made of more than one ion, and what I'm going to do now is I'm going to pass out a list of polyatomic ions that you'll need. So what I need you guys to do is, as I pass out this list, I'm going to pass out this new handout, and I'm also going to pass out the periodic tables that you've been using. What I need you guys to do is I need you guys to get the new paper and just put it on the back side of that sheet protector. Okay, so on one side of the sheet protector, you should have the periodic table, and on the other side, you're going to have the new paper that I'm going to pass out. Okay, so I'm going to start doing that right now. Just take one, pass it down. Everyone is going to need this on their in front of their seats. Just make sure that you guys have both. Okay, so one side is going to be a periodic table, and one side is going to be the new list of polyatomic ions. So I'm just going to eyeball this. So if you guys need more, just ask the row in front of you, behind you. Make sure one side is the periodic table and one side is the new paper that I'm passing. So it's on canvas. Put it on the back side of the. You guys want to print out. Okay, so one side of the sheet protector should be the periodic table, and the other side should be the new paper. So periodic table one side, new paper with common polyatomic ions on the other side. And if you guys don't have one, let me know. If there's extras, I can come pick it up. Oh, thank you. Yeah, you guys need one? Okay, so again, guys, one side should have a periodic table. One side should have the common polyatomic ions. Please just make sure you put it in the sheet protector. You don't need to take anything out, just put it in. Just make sure one side is showing a periodic table and one side is showing the common polyatomic ions. And if you guys are done with that, just take a look at the common polyatomic ions. You do not need to memorize any of these, okay, but you will need to be familiar with what they mean. So take a look at them. You should have this list. This is what you should be looking at. Okay, there's another table underneath that says naming rules. We'll get to that later, but for now, this is what we're looking at, this table with the common polyatomic ions. Okay, so again, one side of your sheet protector should be the periodic table. Other side of the periodic table should be the common polyatomic ions, which we're looking at right now. Okay, so let's talk about these. So polyatomic ions, again, we just said they're ions that are made of more than one atom. So these are like ions, but they travel together in a group. Okay, so earlier we said that when we have like a regular ion, it's like this, right? It's just made out of one element. Okay, but a polyatomic ion is made out of more than one element. So let's look at cyanide for 1 second, okay? You guys probably heard that before, cyanide, some type of poison. So cyanide is one ion, but it's made out of carbon and nitrogen. Do you guys see that? It's made out of carbon and nitrogen. And when it sticks together, it has a -1 charge. So what that means is if we have a lithium ion and if we have a cyanide together, they're going to do the same thing that all the other ions do. The positive and the negative are going to attract with one another and form a molecule. Does that make sense? So it's just the same thing as the ions that we learned about. It's just that these kind of come together in groups. So for example, sulfate has a charge of 2-, which means that we'll need 2 lithiums in order to balance that out because it's +1 and +1. Yeah, what's up?
Is it ordered on where 2- is?
Yes, because that's the charge of the entire molecule. You have to put it in the very back. So
instead of it being right next to the elements,
yeah, it should be at the very end of the molecule. So just copy down the polyatomics exactly how they're written. Okay, good question. Any other questions? Okay, so I know this is kind of weird, but let's do a couple problems to help us understand these polyatomics better. They're just regular ions, so just treat them as, you know, like an O2 minus, a Ca2 plus. Just treat them like normal. Okay, so let's just start, not even by writing the reaction. Let's just figure out what molecule you're going to make. Okay, so if at any point you feel like you can do these on your own, you can kind of zone me out for a second and just check your answer. But for everyone else, let's go through step by step. So it's asking us what's the molecule that's made in a reaction between Ca2 plus and sulfate. Okay, so Ca2 plus obviously has a +2 charge. Now, if you guys look at your table of polyatomic ions, what is the formula for sulfate? Okay, find sulfate on your table. Okay, look at the formula for sulfate. Everyone found it? Okay. So the formula for sulfate is SO4, and it has a charge of -2. Okay, so sulfate is going to be SO4 2 minus. Write that down somewhere on your paper, okay? So again, I'm literally just copying down what is on that chart. You don't change anything, just leave it the way that it's written. Don't move the numbers around. Don't change the capitals and the lowercase. Just write down what you have for the polyatomic ion. So that's sulfate. Okay, so if you guys notice, calcium has a charge of +2 and sulfate has a charge of -2. Okay, so will they be able to balance each other out? Yeah. So what that means, the molecule that's made is going to be CaSO4, and this is your answer. You just put them together. You only need one of each, so you just put them right next to each other. Just like how in our warm-up, we said that you needed 2 Li pluses to balance out 1 O, and so we just put them together like this. Okay, same thing. You just put the positive ion and the negative ion together. Okay, yeah, what's up?
So, another number, like it doesn't matter as long as the positive and negative ions.
Yeah, so you'll change the numbers depending on what is it, the charges, but you do just want the charges to balance out with one another. Yeah, good question. Okay, so hopefully that makes sense. We'll try one that's a little bit trickier, but let's take a look at number 2. Okay, ammonium and oxygen. So take a look. Ammonium is a polyatomic ion. So take a look at your chart and find ammonium for me and write it down on your paper. Okay, find ammonium and just write down what you got on your paper. Okay, so if you guys go to the chart, ammonium is going to be NH4 plus. So this is a polyatomic with a positive charge. So ammonium is going to be NH4 plus. So let's write that down. Okay, ammonium is NH4 and it has a charge of +1. So think of this just as one little unit. You're not going to break it apart or change it. Okay, for the second one, it's asking for oxygen's MCI. Anyone remember oxygen's MCI? Yeah, -2. Oxygen is going to be -2, and this is based on the pattern on the periodic table. Okay, so again, I told you guys you have to memorize it, and it's because we're going to be constantly referring back to it. Okay, so ammonium is NH4 plus and oxygen is O2 minus. Okay, so do we have more positive energy or negative energy? Yeah, negative. There's too much negative energy. So how many ammoniums will I need in order to balance out the oxygen? 2, yeah, good. Okay, so I'm going to need 2 ammoniums because each of them are +1, so I'm going to need 2 of them to balance out the oxygen. Okay, so if we're going to write the formula for the molecule, I need 2 of these. Now, we can't just put a 2 in front of it because these are combining together now. And so this is where we're going to use the parentheses. So I'm going to put ammonium, NH4, inside the parentheses. And since I used 2 of them, I'm just going to put a 2 outside the parentheses. And then I'm just going to put O behind it. So this is the answer for this problem right here. So like I said, we're not learning anything new. We already know how to use the parentheses. We're just kind of mixing things up. It does get a little bit more challenging because you have to use it in different ways. But what you just need to know is how many positives it takes to balance out the negative, and then you just need to put the polyatomics in parentheses if you need more than one. Okay. Any questions so far? Wanted to make sure. Okay, so I want you guys to try number 3 on your own. Number 3 is a little bit different because it's asking you for the cation and anion. So I give you the molecule. I give you the answer that we found here. And so what I want you guys to do is find out what the positive ion and the negative ion that made the molecule is. Okay, so take a look at number 3. Oh, you guys don't all have it out, right? Okay, so take a look at number 3 right here. So Fe, and then you have NO3 in parentheses, and then you have a 2. Okay, so I want you guys to find out, hey, what's the cation? What's the ion with the positive charge? And what's the anion, the ion with the negative charge that makes up this molecule? What is it made out of? So take about maybe a minute. You can work with the person next to you to solve that out, and then we'll go over it together. All right, guys, so I know this might be a little bit tricky, but let's see if you guys got it. So if you guys look at this molecule right here, let's take a look at this thing inside the parentheses. Now, it's in the parentheses, so we have a good guess that this is a polyatomic ion. So if you guys take a look at your chart, which polyatomic ion is NO3? Nitrate, yeah, it's nitrate. Now, if you guys look at nitrate, what is the charge on nitrate? It's negative, right? -1. So nitrate is NO3 minus. So if you look at this molecule, how many nitrates are there inside this molecule? There's 2 of them, right? Because there's a 2 behind it. So that means this molecule is made out of 2 nitrates. Okay, so the nitrates are -1 and there's 2 of them. Okay, that means the cation, the positive one, has to be Fe, iron. Okay, so how many irons are inside this molecule? It's not 2. 1, yeah, if you look, there's no number, right? There's only 1 iron. There's only 1 of these, but there's 2 of these. Okay, so what does the charge on iron have to be to balance out the 2 nitrates? +2, yeah. I know this one was kind of weird and tricky, but you'll be doing this on your assignment, and this is something that we can figure out using the polyatomic ions. Okay, so the cation is going to be Fe2+, and the anion is going to be 2 individual nitrates. Okay, so that's going to be your answer. So this is the cat, and this is the an. Okay, now if you guys notice, iron is in the middle of the periodic table, right? We said the middle doesn't have an MCI, right? But this is how we can figure out what ion the elements in the middle are, by using what it's connected to. If we know what it's connected to, we can figure out what ion things in the middle are, what charge they form. Okay? Okay, we have 2 more examples and then we'll be all done. I'll let you guys get started on your assignment. I'll do number 4 step by step, and then the last one, I'll have you guys try it on your own, okay? So what we're gonna do is we're gonna do what we just did, but now we're gonna write the balanced chemical equation. So before we get started, what I want you guys to do is I want you guys to figure out what is sodium's MCI and what is cyanide. What's the formula for cyanide? So just write that on your paper. Write the formula for sodium's MCI and also write the formula for cyanide. Okay, so start with that. We'll go over that and then we'll put it all together. So you should be looking for sodium's MCI and for cyanide. So I'll give you guys maybe 20 more seconds to write down sodium's MCI and the formula for cyanide as well. Okay, guys, let's go over this. If you're finishing up, feel free to finish that up on your own, but I'm going to start going over this problem together. So if we look at the periodic table, we're looking at sodium, okay? Okay, sodium is in the first column right here. What is the MCI for everybody in this first column right here? Yeah, +1. That means sodium's MCI is +1. And so if we go to our paper, we can just write that sodium's MCI is going to be Na+. Okay, and again, the reason why is because it's on the first column. If it's right here in the first column, it's going to be +1. Okay, now let's look at cyanide. If we go to our table with the polyatomic ions and we look at cyanide, the formula is Cn-. And so if we go to our problem, we can just write down that the formula for cyanide is Cn-. Okay. Everybody good with that? Does that make sense where we got the two, the cation and the anion? Okay, so if we take a look at the charges, sodium is +1, cyanide is -1. Are they will they be able to balance each other out? Yes, because it's +1 and it's -1. So if they combine, they're balancing each other out. So what we need to do for the equation is we're going to put these together. So we're going to write plus. We're going to draw an arrow. And then all we need to do is put them together. So NaCN, and that's it. That's our answer. Okay, we don't need to add any numbers to it because they're already balancing each other out because it's +1 and -1, and they're going to form NaCN. Okay, so here you can see the cation right here balancing out the anion. And on the right side, we don't write charges, no charges, because they're balancing each other out. Okay, and that's it. All we need to do is add some numbers if they're not balancing each other out, but it's basically the same thing that we've been doing up until this point. Yeah. anion. Yeah, so the positive ones are called cations and the negative ones are called anions. Yeah, of course. And remember, cats are good and Annie is bad because Annie's the first girl that broke Mr. O's heart. So she's bad, negative. Okay, so let's finish it up with the last problem, number 5. I'm gonna give you guys 3 minutes to work on this on your own. We're gonna do the same thing that we did last time, basically. But here, we're gonna write the balanced equation for the compound, the reaction between ammonium and phosphate. Pull that up a little, yeah. So this is the answer from the previous one, but I want you guys to solve out number 4 or number 5 on your own. Okay, ammonium and phosphate. Okay, so write down the formulas, figure out how many of each you need, and then you're gonna write the equation just like that from number 4. Okay, so try that out. Work with the people next to you, and then we'll check our answers in a few minutes. It is what it is, and we have our accountability. Alrighty, guys, I'll give you another minute to try that out. Ammonium and phosphate. Okay, you're gonna have to look on your chart for both of them. Okay. And maybe if I could help you guys out, ammonium is NH4 plus, and phosphate is PO4 3 minus. So try putting those together. I know. I'm sorry. I'll try better for you. NH4 plus. Now this is too big. PO4 3 minus. Oh, thank you. Yeah, when I was in elementary, one of my teachers says my handwriting looks like her toilet paper after she wipes it. And I was like, dang, I was traumatized. And I think it made it worse. It's all good. That's why we're learning. Alrighty, guys, let's go over this problem and then I'll let you guys start on the assignment. And of course, during that time, if you need any help, I can help you guys out as well. Okay, so let's take a look at this problem. The problem asks us to find out the reaction between ammonium and phosphate. Now, you're not going to find these on the periodic table. Yeah, I know the clock is buzzing out because the time doesn't go on in this class. Time stands still. It's you. Nobody else sees it. All right, so we're looking at ammonium and phosphate, and so let's take a look at this chart. Okay. All right, so let's look at the chart. So if you look at ammonium, all righty, guys, let's bring it back together. I know the clock is really interesting right now, but it's not going to help you pass. This will. Okay, so ammonium is this, NH4 plus, and phosphate is right here, PO4 3 minus. So we just copy those down exactly as they are. So let's write that down. So we have ammonium, which is NH4 plus, and PO4 3 minus. All right, so if we look at these two ions, they're both polyatomic, but which one do we need more of? The red one or the blue one? Yeah, red one, ammonium. Yeah, I know it's a long word. Yeah, it's only one positive, exactly. So how many ammoniums are we gonna need total? It's +1 and it's -3. So how many ammoniums do we need total? 3. Yeah, we're gonna need 3 of them. So what we're gonna do is we're gonna put a 3 in front of it to show that we need 3 of these. We're gonna put a plus sign, and then now we're gonna put it together. Okay, we just said we need 3 ammoniums. So when you put it together with phosphate, you're gonna put the ammonium inside the parentheses. And then you're gonna put a 3 on the outside because we needed 3 ammoniums. And at the very end, since we only use 1 phosphate, we just put 1 at the end. Okay, and that's it. That's gonna be your final answer. Yeah, what's up? Yeah, go ahead. Okay, so again, we needed 3 ammoniums to balance out the -3 from phosphate. And so when you put it together, we get NH4 inside the parentheses with a 3 and PO4. Okay, so if you want to think about it like this, we need 3 of these little red things, right? We need 3 ammoniums. We need 1 phosphate. And so if you put it together, it's going to look like this. Okay, they're stuck together. You have 3 of the red things and 1 of the blue thing. And that's this right here. 3 ammoniums and 1 phosphate. Okay. All right, so I'll leave this up here on the screen for you to look at. If you guys have any questions or need any help, you guys can let me know. I'll be uploading this lecture on YouTube so you guys can take a look at it for a refresher, but I'll give you guys the rest of the class period to work on the assignment, okay?